heat transfer. So we can define heat transfer as the heat transfer which is defined as a transmission of energy from one region to another as a result of temperature gradient take place by the following three modes. The first one is conduction, the second one is convection, and the third one is radiation. So conduction, what is conduction? The conduction is the transfer of heat from one part of body to another part of body, or from one substance to another in physical contact with it without appreciable displacement of molecules forming the substance. Generally in solids the heat is conducted by two mechanisms known as lattice vibration and transport of free electrons. So the next is convection. Convection is the transfer of heat within a fluid by mixing of one portion of fluid with other. Convection is possible only in a fluid medium and is directly linked with the transport of medium itself. And convection constitutes the macro form of heat transfer, since macroscopic particles of a moving fluid in a space caused by the heat exchanger. The next mode of heat transfer is radiation. We can define radiation as the radiation is the heat transfer of heat from space or matter by means other than conduction or radiation. Radiation heat is through of as electromagnetic waves, and all the radiating body transfer of heat take place from higher temperature to the lower temperature. The conduction. So we can define conduction. Conduction is the transfer of heat through a medium without any flow of the medium. Particle at the heated and vibrate randomly. They collide with neighboring particles and transfer their energy, and eventually the particle at the cooler end are also set into a random vibration. In this diagram we can see easily when we heated a body or when we heated a metal, the heat transfer take place from the one part of the body to the another part of the body due to the temperature gradient. Diagram of the conduction mechanism in solids. Generally conduction take place in solids due to two modes of mechanism. The first one is lattice vibration and the second one is transport of free electrons. The lattice vibration generally take place due to the randomness, or we can say the lattice vibration, the faster moving particle or atom in the host part of a body transfer heat by impact some of their energy to adjacent molecules. And the second one is transport of free electrons. The transport of free electrons says that the free electrons provides an energy flux in the direction of decreasing temperature. Generally in case of gases, the mechanism of heat conduction is very simple. The kinetic energy of molecules is a function of temperature only, and these molecules are in continuous random motion exchanging heat and momentum. Or if we talk about the liquids, in liquids mechanism of heat transfer is nearer to that of the gases. However, the molecules are more closely spaced and intermolecular force come into picture. So this diagram says that when we heated a metal rod, it gained a temperature, and due to temperature gradient, due to temperature difference, the molecule energy, that is lattice energy, increases continuously, and they can vibrate in their places and transfer heat from one place to another place. So this diagram, heat energy is conducted through the solids in this way. As the atom of the solid gain, kinetic energy of the temperature of the solid increases. Conduction is the metals. In all solids, the thermal energy is transferred through the vibration and collision of particles. However, in metal, due to presence of free electrons, thermal energy is also spread through electrons diffusion only. And the last topic for conduction in metals, that is electrons gain kinetic energy and moves more rapidly. They collide with atoms in the cooler parts of the metal and pass on their energy in the process. So we can say conduction take place in solids, in gases, and in liquids also. Is conduction through a plane wall. The conduction through a plane wall, this is a very simple wall having a two layers, thickness L1 and L2, which is maintained at the temperature T1, T2 and Ti, where T1 and T2 are the temperature at the inner side and the outer side, and Ti is a temperature at the interface of these two layers. Suppose we are assuming the conductivity of the first wall, that is K1, and the conductivity of the second wall, that is K2. Heat transfer take place from left side to right side because the temperature T1 is higher than the temperature T2. So there is a huge difference between the temperature T1 and T2. Due to this temperature difference T1 and T2, heat transfer take place from T1 temperature to T2 temperature. So this diagram is a very simple diagram in which heat transfer take place through a plane wall. Law, heat transfer through conduction is follow the Fourier law rule. According to Fourier law, the heat transfer process can be quantified in terms of appropriate rate equations. The rate equation in this transfer mode is based on Fourier law of thermal conduction. According to this law, the transfer of heat or the rate of heat transfer through the material is directly proportional to the temperature gradient and to the area. So in this equation we see the Q is a heat flux and del T is equal to temperature gradients, and K is equal to thermal conductivity of the wall material. The unit of heat transfer is watt per meter square. The conductivity unit is watt per meter Kelvin, watt per meter degree centigrade, and the temperature unit is Kelvin. Temperature gradient unit is Kelvin per meter. So according to Fourier law, we assume some assumptions, that is, number one, heat transfer take place only in one dimension direction or one dimensional, and the second assumption for Fourier law, that is, heat transfer take place only in steady state condition. The third one is the conductivity of the heat transfer throughout the material will be same, and the next assumption for Fourier law, that is, the material should be homogeneous and isentropic in nature, and the last one is the temperature profile between the wall material should be linear. These are the assumptions when we derive the equation for heat transfer through a plane wall. So according to Fourier law, the rate of heat transfer, that is Q, is equal to minus K del T.